This video is a sneak peek showing an upcoming feature in Adapt Builder 2019 related to second order P-delta analysis. In this video, we're going to show an example of a multi-story frame and how the P-delta load combinations are set up and just a few of the graphical results. We'll go ahead and we're going to launch the program with Adapt Edge and Floor Pro. Edge will be needed in order to solve for P-delta. This is an RC only structure. There's no post-tensioning. And for this particular structure, we'll go ahead and we'll rotate, go into multi-level mode. You can see the structure has already been meshed. This structure contains both gravity and lateral seismic loading. So if we go over to loading, load cases, we can see we have EQX and EQY defined as lateral building loads. Under load combinations, there's a new analysis and design option type. So what we have in this example, we have just some general gravity combinations. And then we have 4 strength combinations. We'll focus on these and then the P-delta combo. So we have EQX positive and negative, EQY positive and negative, and those are set to strength. So here we'll just get a first order linear elastic result from those particular combos. We also have additional combinations now set to P-delta, and if we select the pull down option, we can see we now have this P-delta setting where we can tag combinations for P-delta. Now in this example, I want to create a batch solution. So what we're going to do is we're going to set up a combination. We call this P-delta matrix master, and here we're going to define the gravity load cases that we want to include for the production of a geometric stiffness matrix. That matrix will then be used for subsequent P-delta combinations that include identical load factors in terms of gravity. We also have factors for EQX 1, -1, 1, -1, but those will just be additional load cases produced or producing a result for that particular combination. The geometric matrix is then used in combination with the general matrix for the structure, and we produce a solution for each subsequent combination based on this first initial P-delta combination without the EQX. Now, if we wanted to produce individualized combinations, then what we would do is we would actually remove this. The program would then solve these singular wise where we would produce a geometric matrix for each individual P-delta combination. So this is the way we're going to set up the batch by producing this primer combination, if you will. We'll go ahead and say OK, and we're going to now analyze the structure for the entire set. Now the reason we have strength combinations matching the P-delta is so we can compare the moments. We may want to compare what's our first order moment versus our second order moment. Just by solving the P-delta, we're actually going to get a ratio and an amplification factor that the program will report graphically. So we'll go ahead and we'll solve this. Okay, we're going to select yes to save that. And I'm now going to go over to column design just to isolate all the columns. Okay, that's just a quick and easy way to isolate the columns. Under the result browser settings under loads, we have this set called P-delta. And that's just a new load analysis type, P-delta. For example, if I look at strength EQX positive, okay, and I go to analysis, and under columns, maybe I want to produce the moments about the local S-axis. Okay, that's the axis where we'll produce the primary bending for this application of load in terms of the seismic direction. If we go to action, I'm going to look at the moment about S. Okay, and we'll pick a column here just to review. You can see we have different moment values along the height of this column. We'll kind of look at the bottom moments here, 44 and 64. That's for strength. Now, if I come back to loads and I look at the P-delta combination, or excuse me, the regular strength combination, we have 44, 64, The matching strength first order combination produces a result of 43 and 58. So we get a little bit of a bump there due to the P delta effect. We can also see this more directly using moment amplification factors. So for this particular combination, again, strength EQX positive, P delta, we can check the amplification factors for the column. This is about the RR axis. You can see this is 1.01, 1.03, and then we have 1.21, 1.1. Okay, and those particular checks are made and they're flagged color-wise against a setting. What's our maximum amplification factor that flags this acceptable versus unacceptable under display? We can go ahead and set that setting, and that setting is shown here, moment amplification max allowable. Okay, so the allowable is shown here. Coming back to loads, if we were to produce the same result for other P delta combinations, you can see this value will change per combination set. And then I can also change the direction and come back and again work through the load. So this strength EQX negative is actually producing that controlling ratio. It's 1.48, which flags it as unacceptable. In addition to these graphical results and just general frame solution and the results obtained from that solution, we can also design for the P delta effects. So from column design, once we go into the design settings, we have the ability now to determine which combinations we want to choose to design for. And here we can actually set up the ability to design, let's say, for these combined gravity lateral combinations, including those amplified P delta forces or moments in the structure. So the same process is used for column design, it's just that we have now the ability to include these combinations. If you have any questions about this upcoming feature, please let us know at support@adaptsoft.com. Thank you.